Hello. Okay, so this is now attempt 3 at making this video. Don't ask me about attempts 1 and 2, or do, but wait till next week when we're live. Alright, so we have done chapters 1 through 6 already. I'm going to review chapter 6 in this video, 6 being differential equations, slope fields, that sort of stuff. And then 7 is going to start next week. It is area and volume. And when I'm talking about area and volume, I'm talking about area between two curves, so like root x and x squared, something like this. And finding the area between these is pretty easy, so that's going to be no problem. When things get a little more exciting is when we revolve this area around the x-axis here. Because we create something that looks something like a really weird bowl with a super unuseful inside. If I rotate this around, so this is in 3D, these are circular here. And so what this is used for is finding the volume of things with rotational symmetry, and you'd be amazed how many things in the world have rotational symmetry. If you just look around where you're sitting, pens, screws, bottles, there's just an amazing amount of things with rotational symmetry, specifically because we have a lot of tools for dealing with rotational pieces. A lot of our machining tools have rotational powers or abilities. And so this is a very helpful idea for the basis of a lot of that stuff. And that's what we're heading into. That's chapter 7. Again, the new instruction will start with a live stream that I will be posting soon. I don't have my streaming schedule yet because I'm still, my Algebra 1 team's all shooting emails back and forth trying to figure out how and what we're covering and when. So that's a little up in the air. When we get that schedule nailed down, I'll be able to work in calculus. But expect something like Monday, Wednesday, Friday live streams. I would love if you could attend or watch them in between. If you can't, I'm going to try to do them during school hours, somewhere between 10 and 3. It's not going to happen before 10 because I am not often up before 10. If I don't have to be. And so it will be during normal school hours when you probably don't have other things planned because quarantine. Hooray. All right. Moving forward, I have some questions prepared. Some of these are new. Wow, like this one. Oh, crud, did I close my other thing? Oops. So, on that note, let's do the one that I prepared here. So this is an entirely new question, so this is a pretty helpful review tool. Part of the reason I did this is I did this wrong by misreading the question entirely and solving a new question. Wow, good job. All right, in this question, you have a slope field for a differential equation. And the differential equation's up here, but we don't need it for the slope field. It's already drawn. This question's a little weird in that it asks us to sketch the solution curve. So if you look at your notes for slope fields, there's a reason I put quite a few of these sketch the solution through the curve parts on there, and this one actually looks almost exactly like one of those. It might be exactly one of those. No, the numbers are a little different. It says find the solution curve that passes through 0, 2, and the solution curve that passes through 1, 0. And by find them, I mean draw them. And 0, 2 has a really easy solution curve. The graph is straight up flat there. Cool. Through 1, 0, the solution curve is a little harder. It's definitely getting more and more steep. Then it's getting less and less steep, flattening out, and then going back. So this thing should look somewhat symmetrical. Mine is okay. It's actually better than my first attempt, so seems good. And that's it for the first one. That's like a 2-pointer. We already knocked it out of the park. For B, it says find a tangent line. Tangent lines with differential equations are really easy because you already have the slope equation. No calculus is required for this question. All I do is I plug in the point they give me into the slope equation. And so, what's the point they give me? 1, 0. So x is 1, y is 0. So I plug in 1 for x, and I plug in 0 for y. And all I get is 4/3, because this is negative 2 squared. Cool. Slope acquired, y minus y1 equals slope times x minus x1. If you don't know point slope form, learn it. It's so useful. It just makes every one of these equations like gravy to get to. Boom. First point of b acquired. Alright, now that we have this, we're just going to plug in 0.7, and we get y equals 4/3 times 0.7 minus 1. So y equals negative 0.4, because negative 0.3 divided by 3 is negative 0.1, and times 4 is negative 0.4. You don't need to simplify your answer fully. If you leave it as negative 1.2 over 3, that's okay. On the AP test, they're not super picky about your simplification. It's that you get the right answer. Okay, now, before I move forward on this, I'm going to idiot check this real quick. And by that I mean I'm going to go to 0.7, which is roughly here, and I'm going to look at my value on my curve. And yeah, that's a negative small value. So, sick. That means it actually checks out. Idiot check complete. My answers match between A and B. And we're already 4 points into this question. 2 points to the picture, 2 points for this tangent line stuff. We haven't done a lick of calculus. Now it's calculus time. So I'm going to clean the slate here. Dun dun, clear all. Wait, no, let's just erase. Dun dun dun. And now we're going to do the calculus part of the question. Okay, for the calculus part of the question, remember this section is called separation of variables in our notes. Not solve the differential equation, even though they say find the particular solution to the differential equation in the question. So to solve the differential equation, I need to separate variables, and that's an always thing. So if I separate variables, I get dy over y minus 2 squared by dividing both sides by y minus 2 squared to get the y on the left. Equals 1/3 x dx on the right by multiplying dx to the right. This is separated variables, and we're already 1 point into the question. So, even if you don't know how to solve these, please remember that separation of variables is step 1, because if you separate variables right, you get a point. Then you have to integrate these rights. And that's actually worth 2 points, one for each side. And the right side's like super easy. Cool. That's the right side. You just integrate x to x squared over 2. You put a plus c. Okay, so the left side is a little harder. dy over y minus 2 squared is y minus 2 to the negative 2 dy. This rewrite's really important. This rewrite prevents you from doing wrong stuff, like calling this natural log of y minus 2 squared. That's not the answer to this. Natural log only works when you have a power of 1 on the bottom, and we have a power of 2, so no natural log here. If I integrate y minus 2 to the negative 2, I get y minus 2 to the negative 1 over negative 1 equals x squared over 6 plus c. I multiply both sides by negative 1. I get y minus 2 to the negative 1 equals negative x squared over 6 plus c. I flip both sides, which means I negative 1 power both sides. And I get y minus 2 equals, what do I get on the right side? 1 over everything on the right side. Cool. Okay. Now, there's a little bit of a nuanced step here. I want this x squared to be by itself. So I'm going to multiply this right side fraction by negative 6 over negative 6, which is 1, but allows me to rewrite this in such a way that it's a lot simpler to look at. This is an optional step, but this is absolutely a step they use on the AP tests to solve these kinds of questions. So their answer is almost always going to look like the answer we get if we do this sort of thing. Okay, if we do this thing, we get negative 6 on top, we get just x squared, which was the entire point of doing this, and we get a new plus c. So I'm going to update my old c to be a different c, like c0. Cool. Now that I've done this, I just add 2, and I get y equals 2 minus 6 over x squared plus c. And all I have to do left is solve for c. So c in this question relies me to use the initial condition 1, 0. So I plug in 0 for y, and I plug in 1 for x, and it looks something like this when I do that. I add this fraction over to the other side, and I get 6 over 1 plus c equals 2. I multiply both sides by 1 plus c, and I get 6 equals 2 plus 2c, so c is 2. And this allows me to write my final answer. Where am I going to put this? This is very full. So where should I put the answer? Bye-bye first half of the problem. Okay, I get y equals 2 minus 6 over x squared plus 2. Hurrah! And that's the last point in the problem. So as far as points went, separation of variables, or step 1, worth points. Each of the integrals, worth of points. So we're up to 3. Solving for c correctly, worth of points. So that's 4. And getting the final answer where you get y equals, worth a point. So this was a 5-pointer. So the points were 2, 2, and 5 for this. And all of these were pretty attainable. Like, weren't too horrible to actually solve for, which is kind of nice. Alright. Let's see if I can find the other question. Whoops, that's uploading videos. That I wanted to talk about. Downloads. Yikers. These are not organized the way I wanted them. I think I'll call it here and talk about more during the stream. I'm a little tired from uploading videos and stuff. But I wish you the best. I will be around on Monday streaming this unless I get the flu or something or the sickness. In which case I'll keep you informed and cancel things if need be. But I hope this video helps you remember a couple things about differential equations and give you an idea of what's coming your way in the future. Feel free to ask me any other questions come Monday when we start streaming. Please show up if you want to ask me questions. Otherwise, you can email me questions at any time, and I will be responding to any of those as best I can. Maybe I'll respond with a video and just send that to you if that helps compared to just writing out a whole bunch of text. So please, please, please feel free to make me work because, to be honest, I have enough time. I don't need to play more video games. So holler at me, make me do things. That's fine. Bye-bye.